mathematical thinking. Oh, good. Well done. I forgot to start that. Thank you. Oh, yes. Oh, I'm going to do that. Okay. So consequently, this afternoon, I'm going to offer you some tasks. It's the only way I know to work, is to give you some tasks to do through which, and on the basis of which, I might be able to make some observations about noticing and about attention. So that's what's going to happen. I would love to be able to use breakout rooms and to get you to talk about what you're thinking, but I suspect I'm going to be pressed for time. And so I probably won't be in the end up do breakout rooms, but it's a very important. Yes, one of the things I often say is that if you don't engage with my tasks, I can guarantee you'll get nothing from the talk. I have nothing to tell you except what is in relation to experiences that you have by working on some tasks. Oh, come on. So another thing that's really important is that everything that is said here, and in my workshops, everything that's said by anyone at all, but especially by me, is to be taken as a conjecture which must be tested in your experience. You must not believe anything I say. Some very famous people have actually said that. Don't believe anything Mason says, test it in your experience. These slides will be on my website after the session, and I'm hoping that the recording will get there as well. I'll let you know how to do that when we get to the end. Right. So I like to play with language, and I don't apologize for that. There are three words that I quite like: retrospective, that's in the past; prospective, that's into the future; and then spective, which I take to mean in the moment. So here's a question for you. Have you ever finished a lesson, teaching a lesson probably, and wished that you had acted differently in that lesson? I see a couple of nodding heads. I can only see 3 heads, and at least one of them is nodding. So that's great. That happens to me frequently. For example, I was interacting with one of my grandsons recently and suddenly realized that when he asked me for help, I had told him what to do rather than inquiring into his thinking. So my action, in retrospect, thinking back on it, I wish I hadn't done that. I wish I'd done something else. So the discipline of noticing becomes useful here. So retrospectively, I became aware that I was using imperative rather than, gosh, I can't see my own slides. That's really awkward, isn't it? I don't know how to deal with that. Is there some way I can do that? No, that was a bad idea. The imperative teaching, imperative pedagogy is when you tell students or learners what to do. And there's a lot of that in this country at the moment. And I regretted that. And so what I'm trying to offer here is an example of retrospectively becoming aware of an action that I wish I hadn't done, but rather the better way to think about it is what I would wish to do in the future. So what can I think of, what can I prepare myself to do in the future that would be different? So acting in a way I'd like to act rather than in a way which was automatic and habitual. So have you ever intended when planning a lesson to initiate some pedagogical action? That's fancy language for act in some way. And then you've forgotten all about it in the moment, just never remembered to do what you planned to do. That happened to me a lot when I was doing teaching. And the discipline of noticing is designed to sensitize yourself to the possibility of acting freshly. Put another way, to make it more likely that a suitable action will become available when it's needed. Because one of the problems, I guess, similar questions I could be asking are, have you ever been stuck on a mathematical problem? I'm currently stuck on at least 5. And the problem with being stuck mathematically is that you don't have an action to carry out, a mathematical action to carry out. As soon as a mathematical action becomes available, you do it. The same thing happens in classrooms. You do what you're trained to do, what you're habituated to do, unless you notice an opportunity and catch it and choose to act freshly. So the discipline of noticing is designed to turn this kind of work into a respected research activity. But I'm going to suggest to you that the noticing, as you've already found from the previous webinars, noticing is at the core of teaching, of thinking mathematically, of what else was I thinking? Teaching teachers, and carrying out research, of course. So in the session last month with Susan and Vicky, the focus was on one particular kind of situation in which noticing is vital, namely learners' response to a task. So you give learners a task, they respond to it, and now what do you notice? And what you notice is what you're attuned to notice. So the discipline of noticing is basically how to attune yourself to notice freshly. And here's an opportunity for you to catch how your attention works. So here comes a mathematical problem, and I'm going to give you a little bit of time to think about it. Ideally, I'd like you to go into breakout rooms, but I don't trust the time at the moment, so I'm not going to do that. So you have 43 paper clips, and I have 27. How many paper clips must you give to me so that you have only 4 more than I do? Now, I'm not interested in the answer. I do know the answer. What I want to invite you to be interested in is how you think about it. What do you start attending to? I'll give you a few moments to think about it. I promise you that if you just sit there and think, you won't get nearly as much as if you actually write something down on a bit of paper, because it's how you choose, how your body chooses to start writing, which is the mathematical action which has been triggered. And that gives you evidence of that mathematical action. That's what's of interest. Daniel, do you want to try saying something? I think it's going to work better if people put things in the chat. Good, so people are putting in their responses in the chat. But what I would like to invite you to attend to is what you did, not what the answer is. So because interaction is really difficult here, I'm going to offer you a couple of strategies. And what I want to invite you to do with these strategies is to watch how you make sense of them. Whoop. So strategy 1. Watch what you're doing to make sense of what's appeared. Here's another strategy. And here's a third strategy. Now, almost certainly your own strategy was different from these, but I may draw attention to the strategy one, which I would call being systematic. So making systematic variation, basically giving me one paper clip at a time in order to see what the effect is and building it up until you get to the desired response. But what's really of interest, I think, and what's of important interest is how you made sense of these strategies. And that's at one level. And then, and that compares to trying to make sense of what learners' strategy might be. And then looking at what are what opportunities that gives you with respect to the original task. So for example, oh yes, I want to make some conjectures now about what you did when you were looking at those strategies and at the task. There was an initial phase of gazing at the screen. It might have lasted for only a microsecond, but there's a moment when there's just the screen, there's just stuff on screen. And I propose that actually is a really important aspect of mathematical thinking, and that we gaze not just at the beginning of things, but frequently we just pause and gaze for a few moments. And there's a lot to be gained by learning to gaze for longer than just a few seconds. So for each strategy in turn, I think that you gazed at the strategy. In fact, as the details were revealed, you gazed at each line, and then you started discerning details in what was revealed. So each line, you noticed that there were numbers and subtractions and an equal sign and a calculation. And you may or may not have been relating the sequence of lines, in the strategy with how you were likely to think about it, how you thought about it. Or you might have been checking calculations as well. And I'm hoping that you found yourself recognizing relationships between the steps in a strategy, because it isn't a strategy until you see it as a sequence of steps to be carried out for how the answer is to be found. And below the surface, there's a personal narrative as to what the strategy is, which is, of course, what you're doing when looking at children's work, what Susan and Vicky were calling interpretations. We'll come back to that in much more detail in a minute. And I suggest that you were perceiving properties, which is another way of saying becoming aware of generality. Because I'm hoping that you said to yourself, can I see how to use each strategy for other differences, not just or for other constraints? And how do I know that the strategy will always work? So you've moved into the realm of generality, of variation. So I'm hoping that this has given you just the beginnings of a taste of different ways of attending. And I'm going to suggest to you that noticing is basically a shift of attention. You notice something when your attention shifts. And so what strikes me as being important is to pay attention, to become aware of, to pay attention to how my attention shifts. because I then want to be able to to listen to watch learners and to see if I can catch their attention shifting in a way which corresponds to the way I'm thinking. And if I don't see them doing that, I can ask myself, what kind of pedagogy can I use so that they start to experience the shifts that I think are important mathematically? And one of the questions that's always around is what is the same and what different about the three strategies, the relationships between those three strategies. We haven't got time to go into that. So here are the three strategies again. And mathematically, I have the questions of what can be changed and still I can use the same method. Now, what you learn from my asking that question is that I am sensitized to generalizing or extending tasks. So I'm not interested in 43 paper clips and I have 27. I'm interested in a situation in which there are two things and there's an adjustment is necessary. This is related, this task is related to the phenomenon that surprises some people. If there's been voting of 4,000 people voting one way and 5,000 voting another, how many people need to shift their vote until it's equal? And it's not the difference, it's 500 people shift their vote, and so on. So there are lots of different situations where this same phenomenon takes place. So these are questions that I have attuned myself to ask about any task that people give me. What relationships must hold between the starting numbers and the final difference? If I'd asked for 5 more, would that have been possible, for example? Lots of things to explore. What properties must hold for an answer to be possible? And what if you're supposed to have 4 more than twice as many as I have? What happens? So there's all sorts of variation, and it's immersing learners in situations in which they begin to see that they can ask themselves these questions, that I think they are really beginning to think mathematically. So one of the things I can be noticing if I'm trying to notice children's or learners' mathematical thinking is, do they make changes? Do they vary? Do they repose questions, extend questions, for which they can still use the same strategy? And if they begin to do that spontaneously, then it seems to me that this aspect of mathematical thinking has become established. But there's also another level, which is if you were a colleague or helping a colleague or a learner, what pedagogy might be useful if they were stuck? Now, I haven't got time to address that question, but I want to draw your attention to the pedagogic level as well as the mathematical level. So I've got a little bit more on attention. I conjecture that very early on, but 2 slides ago, when you first saw that task, you asked yourself, could I use this with my learners? Or why would I choose to use this type of task? It's very common as an active teacher. Every time I come across a task, I find myself wanting to ask, could I use this? Would I use this? For what reason might I use this? And that's all about noticing. It's what I notice in a task is its generalizability. That's what I'm attuned to notice. You might be attuned to something quite different, like to what extent does the task promote discussion between the learners? Or you might have lots of different interests. And so you might notice quite different things about tasks, the language in which it's embedded and the context in which it's presented and so on. So noticing for me, and I'm stressing me, there's an opportunity in this task for learners to encounter being systematic. Not all learners, not all people are naturally systematic. when they encounter situations. So being systematic is something that's worth learning. I notice that there's an opportunity to promote generalization, and I notice an opportunity to promote learners constructing their own variations. So for me, those are 3 out of many opportunities which that task offers. There are others I can think of, but I didn't get around to mentioning them. So that's a taste of noticing different ways in which you attend to things, or what I call shifts of attention between, well, I'll come to the details in a minute. I got one more task here, which I want to offer you to give you a chance to think about the things that I've just been talking about. So I'm going to invite you to find 3 different numbers as fractions between 7/4 and 8/5. You'll need pencil and paper, I promise you. Well, I did anyway. Let me remind you, I'm not interested in your answers. I'm inviting you to be interested in how your attention changes as you work on the task. Right, as I say, I'm not interested in answers, but here, again, I want to offer you several different strategies. And again, it's an opportunity to catch yourself trying to make sense of the strategy, how your attention shifts, how you gaze just briefly, you have the sense of the whole, and then another time you might be discerning some detail. You might then gaze at that detail for a bit. You might suddenly recognize a relationship between a couple of details that you've discerned. That's the kind of thing which I find really useful, and not just in doing mathematics, but in thinking mathematically, but also in carrying out research and working with teachers and so on. So I want to offer you a conjecture. When you first saw the task, you gazed at the 2 fractions. I can't remember what it says underneath the picture there. You might even have wondered which one was bigger. at some point you saw them as actual numbers and you guessed which one was larger, but did you check which one was larger? So easy to make an assumption that it's the 7/4 is going to be smaller than the 8/5 because the 7 is smaller than 8 and the 4 is smaller than 5. And then you, at some point, you wondered how on earth you were going to find fractions in between. And you may have contemplated converting to decimals, but the problem is you've been asked for fractions, and so it's quite likely that you're going to stay with fractions. Another conjecture, at some point, a mathematical action became available, something to do with discerning finer distinctions in fractions, because you wanted to create more fractions. And that means increase the denominators. So that the action of increasing the denominators probably came to you at some point, and with it, and some sense of how that produces the numbers that you're looking for. And I want to suggest that this is absolutely typical, that you're in a situation and suddenly an action becomes available to be enacted, and it gets enacted before you even think about it. There's lots of neurological research which actually justifies this ancient, I would say, Sufi awareness, if not much older, that that actions that become available get enacted before the forebrain, the intellect, actually thinks about whether or not they're going to be useful. And there are several strategies that tend to come to people. So I've come up with 4, and let's see what you think. Strategy 1. Notice how you saw some numbers with the fraction line, vinculum, and at first, and then you discern the 8, the 5, the 32, and the 20. At some point, you asked yourself, are they equal? And you related the 5 to the 20 and the 8 to the 32. So you were looking at a relationship, and that was an instance of a property, because you know that if you multiply the top and the bottom by the same number, then the fraction value will be the same. So similarly, now I can see which one's larger, and I can see how to get something in between, because I can do 33/20 and 34/20, but I need 3 of them. So one strategy seems to me to be to do the mean of them. Here's a second strategy. Now, what would be really nice here would be if you found yourself saying to yourself, so if I was asked to do 15 numbers in between, I could just keep on doing means until I had 15 numbers in between. That's that move to the generality. That's the sense of becoming aware of the strategy as a strategy, not just as a sequence of actions. One of the things that happens for learners when they're shown a worked example, which these are both worked examples, is that their job is to work out how you know what to do next. The research demonstrates this, that it's not what you do next, but how you know what to do next, and whether it's applicable, whether it's actually, it's a useful action. And that involves having a general story, a narrative, thinking of the strategy as a property, as a generality, which then you can instantiate, you can use in a particular situation. Strategy 3. Well, that takes a bit of looking at. Where did that 15/9 come from? That's the kind of question which I think you find yourself asking. You've gazed at it briefly. You see that there are three numbers with inequality signs, and so your attention quite naturally goes to the middle one, the unfamiliar, the new one. Where did that come from? Now, in most schools everywhere in the world, where 15/9 came from is people try to not have anywhere close to the classroom because they think it confuses children. However, it turns out to be one of the most useful actions on fractions, but that's another story for another time. So if you accept that that worked this time, then you can do it again. And what this is meant to raise is, does that always work as a strategy for finding things, but fractions between fractions? And if so, why? If not, why not? When not? And strategy 4, I couldn't resist keep on constructing strategies. So it seemed to me I could take the difference, and that I need three numbers between 1/20. So 1/20 isn't a big enough gap. I can't just add 1/20 twice, because the third time I'll get to the 8/5. So I need to make a smaller gap, and so take 1/40, and that gives me three numbers that are in between. In fact, it gives me access to a bunch more. And then I can ask myself all these questions about what's the relationship between the strategies, and what strategy uses the smallest possible denominators, and would that always be the case? These are the kinds of questions which I think we want to be promoting learners to be asking themselves about the tasks they're given. It isn't the answer to the task that is of interest. It's becoming aware of the variation in the task, which you can still do the same way, because that A prepares you to answer questions on an examination, but B, it gives you this sense of power, of generality. I can do any question of this type. And underneath all of that is, how do learners learn to notice that opportunity when they're working with a task? And the answer to that, of course, is that the teacher engages them in that kind of activity over a period of time, frequently asking them, what can you vary and still do it the same way? And then eventually asking them things like, what did we do last time with a task like this? Which comes under the notion of, in the literature, it's called scaffolding and fading. I call it directing, prompting, and spontaneous actions by the teacher or by the student. So that the student is directed, then they're prompted indirectly, and eventually they spontaneously do it for themselves. So that's a pedagogic action which to be initiated over a period of time. And the first 2 or 3 times I intend to do that in a classroom, I might forget, because I'm so caught up in getting the answers and seeing if they get the right answers, that I forget to do the thing I really wanted to do. And so the discipline of noticing is really about how to remind yourself how to how to have the right idea, the idea that you want to have, come in the moment that it's needed. So I think we should pause there. What's that? 9. Oh, right. So I was going to relate that to oops, that's not the right thing. That's right. There we go. Right. So conjectures. With each reveal of a line of a strategy, it seemed to me there may be a moment of gazing. Just holding something. I call it holding a hole, gazing at some part of the screen, and before starting to be analytical. There's discerning specific details in what you've been gazing at. So discerning, for example, the 8/5 was written as 32/20, the 7/4 is written as 35/20, so these are comparable, and so on. So discerning those kinds of details. There's a recognizing of relationships between them. So 8/5 is less than 7/4, and I can see it because of the 32 and the 35. And I can perceive a property as being instantiated in a particular relationship that I've recognized. Now, to me, what I found these really useful, I know it's quite a lot of material, but I found them really useful for helping me to become aware of what it is I want learners to experience. So I've done that by starting with myself and becoming aware of how my attention shifts. And then I can use that to act pedagogically in various ways, which invite the learners to experience the same thing. And in the process, become aware of mathematical thinking and reasoning with properties. And what's really, really important about these is that although they're very, very similar to Van Healy levels, they are not levels. I want to say that again. They are not levels. Oh, that's going to come out in a different slide. Sorry. Okay. Anyway, I'm going to say it a third time. They are not levels. They happen back and forth. Moment of gazing, recognizing a relationship, discerning a detail, perceiving a property, gazing again at where some property is holding or not holding, gazing at a relationship. These things, for me, they happen back and forth, back and forth, back and forth. So one of the pedagogic questions is, how might learners' attention be drawn to these as potential actions? And as far as I'm concerned, it begins with noticing them in myself so that I can then notice opportunities to try to direct the attention of learners. Because as I'm going to say somewhere else, teaching is basically interrupting somebody else's attention. That's what teaching is. You interrupt their attention, you try to direct their attention somewhere else. You try to shift their attention. And so I need to know what different ways are of attending in order to be able to choose to act sensibly. So here's a summary. Noticing arises from a shift of attention. For example, you might have been attending to my accent. In this country, I've only been here for 53 years, but it's still the case that people after a session will ask me, where is your accent from? Where are you from? So I know when people do that, that some of their attention has been on my accent, not about the pedagogy, the mathematics, the noticing, whatever that we're supposed to be talking about. So all noticing arises because of a shift of attention. And I find that this way of thinking about attention is really helpful, and it helps in research, it helps in teaching, it helps in doing mathematics. Holding a whole, actually, when I was gazing. Have you ever been stuck on a mathematical problem? Perhaps you're looking at a geometry problem, there's a figure, and you gaze at the figure, and sometimes nothing happens. And sometimes something happens, something suddenly pops out for you. You become aware of a detail, for example. So discerning details, picking out little bits and things, and then attending to them. When you go to an art gallery, that's what you're doing with paintings. You gaze at the whole, then you become aware of some detail or details in the painting. You start to ask yourself, are there relationships between these details? Are they trying to tell me something? Is the artist trying to say something? Well, it applies to everything, not just mathematics. Perceiving properties. For me, the shift between recognizing a relationship in a particular situation, like 8/5 is less than 7/4, and perceiving a property as being instantiated. In other words, if you add one to the top and bottom of a positive fraction, it gets smaller. Well, if the numerator is already larger, then it'll get smaller. So there's a property going on, and reasoning on the basis of properties is what people call proof. And there's a lot of interest in proof at the moment in mass education, as there is every generation or so. But reasoning is only possible if you're aware of properties. And one of my observations is that it's the relationship between recognizing relationships and perceiving properties, which lots of kids seem not to appreciate. It's where arithmetic ends with recognizing relationships and mathematics begins with perceiving properties, the generality. And I suspect that lots of kids never really get that message, have that sense of the shift from the particular to the general. But I've been claiming that for a long time, so there it is. And I want to stress, here it is, that these are all different states, different ways or different forms of attention. They are not cyclic. They don't happen in a specific order. They're not levels. So that's where I disagree with Pierre and Dina, who are no longer with us, of course, unfortunately. Now, last time, Susan and Vicky were talking about noticing and interpreting and responding. And it seems to me that interpreting is really a way of describing the shift between recognizing relationships and perceiving properties, because that's where you're saying, what this child is doing is this, or I wonder if this child is doing that. So, my feeling is that that's where interpreting is coming about. And responding, you can respond automatically, which is of course just doing what you're habituated to do without really considering it in the forebrain here. Or you can do something, I call it considerately, by considering. To consider means literally to sit with. Con is with, and sidere is from the Latin for sitting. To consider something is to sit with it. That's like holding holes, isn't it? It's like gazing. You sit with it for a period of time. But so reasoning, taking the time to reason on the basis of properties when you're teaching, to ask yourself, is it appropriate for me to tell this child what to do now? Or maybe I should ask them what they're thinking. So take the opportunity to act freshly. So that's what, for me, the discipline of noticing is about. So I'm going to move on to research activities now. And from my point of view, and this is very radical, you mustn't believe any of this whatsoever. There are three kinds of research. Well, let's work with two kinds of research. Think of research as inspecting things, observing, finding out about things. Most research which is published these days is extrospective, which means that one person up at the top there looks at other people doing things and observes them. So all that person has is behavior. You've got things that are written, things that are said, gestures that are made, tone of voice and facial expressions, which might indicate some sort of emotions. All you've got are the external forms. And so that the traditional research is what I call extrospective, from the outside, inspecting from the outside. And what I found is that it's much more interesting, and also a real challenge, to work introspectively, to work inside myself. So to observe what I am doing, and then introspectively negotiate with other people as to whether or not they experience it. So if I were being fully with the discipline of noticing, I would have stopped and I would have asked you what you noticed in those previous two tasks, and engaged you in a discussion about the sorts of things you were noticing, and offering different language, some sort of technical language perhaps, because it seems to me that you'd notice something really valuable and important and worth looking out for in the future. So the introspective is the seeking resonance with other people. That's what you're supposed to do with a scientific paper, except that it doesn't very often happen, but I didn't say that. So introspectively, meaning you are developing an inner witness who witnesses, who watches, who observes what you're doing, and then helps you reflect on that, become aware of it in the past, when you're thinking back retrospectively. And then introspectively, where you're trying to get resonance with other people. Sometimes people don't know what I'm talking about. Probably is the case today. Some people just don't know don't have the faintest idea what I'm talking about. And that's a failure of introspective. It means that I haven't found specific tasks which bring enough experience to the fore that you recognize the sorts of things I'm talking about. I'm hoping that there's been some introspective activity so far. Now, there are lots of problems with observing. Observing other people seems to me to be fraught with danger, but so is observing yourself. And so here are some examples of the sorts of things that can happen. So I love the slogan, say what you see, but because we're not in small groups, you're going to have to say it to yourself. So see if you can get enough energy to speak out loud, even though there's nobody else with you. So you actually say it out loud to yourself. A 12-year-old was asked to talk about the expression 3x plus 6. She said, 3 is an odd number and I don't like odd numbers. 6 is okay because it's even. This I'd forgotten that this example was coming next. So what I just said about say what you see will apply to one of the later slides. So here, what do you make of this incident? It seems to me that it's very tempting to say that this child doesn't actually know what the X is and what the plus sign is and what the equal sign is. They just don't know it. But it might be that they don't see it. They don't actually see it, much less they don't know about it. But what strikes me is that there's no reference to the X. There's no reference to the plus and the equal sign. Is there an equal sign? No, just the plus sign. Sorry. So what can be said of what is being attended to? You've got to be very careful. You can't say that they're not attending to the X. All you can say is that they didn't mention the X. And that's true whenever you're using the construct of noticing. When all you've got, because you're working extrospectively, what are other people noticing? Then in that situation, all you've got is their behavior. So you can't say they didn't notice. All you can say is they gave no evidence of noticing. And as here, it seems to me that the times and the X and the plus may have been overlooked, not noticed, or the pupil may not have known what to say about them. Or they didn't see them as being as important as the numbers. And it might be that emotions are guiding and focusing attention. They're frightened of the X, for example, or they don't know what to do with the plus sign because they can't collapse it into a final number. Lots of different things that could be going on. Now, here's the one where I'd like to invite you to try and say out loud to yourself what you see. You ready? Here we go. The careful researcher says what they see are some gray regions separated by some white lines. The incautious researcher, the one jumping to conclusions and interpretations, says, oh, I see a hole in a doorway with a cube behind it. Here's another one. The careful researcher says, I see 1, 2, 3, 4, 5, 6, so eight gray discs cut by, each of them cut by 3 white lines. But it's so tempting to say, I see a cube, a white frame of a cube. And there's one more. It's so hard to not see the white V's in each of the circles extending into the white space in the middle, but I promise you they don't. So this is where I haven't actually written it up on the slide, but this is where I found it really, really helpful to distinguish between an account of what I observe. I observe 1, 2, 3, 4, 5, 6 gray discs with a white V cut out of them, for example. Or it might be other ways of describing that, of course. That's an account of what I see with as little interpretation as possible, or accounting for, which means, you make the picture by drawing 6 circles on the corners of a hexagon, and then you draw the star-shaped thing. And that's the work of learning to be a researcher, is to learn to cut yourself down to account of, and to resist accounting for until you've got some agreement with other people as to what you're giving an account of. Anyway, there's a lot of that in the book, but I haven't got time to go through all those details now. So, where are we? 14. Oh, yes, there's one more example here. Oh, yes, sorry. The current zeitgeist has the brain, sees the human brain as a predictor of imminent action. The brain actually predicts what you're going to do next and prepares your musculature to do that. And the job of mindfulness, the job of noticing, is to park the first impulse that comes to you and to ask yourself, is there something that might be more effective? These examples are all based on the Gestalt tendency that we have. It's part of our wired-in brain to fill in or complete a picture from bits and pieces that we're familiar with. In other words, the brain is predicting what is there, rather than focusing on simply what it sees. And this applies to recognizing mathematical patterns. It applies to recognizing learners' behavioral patterns. It applies to recognizing opportunities, recognizing possible pedagogic actions, and recognizing possible use of something as research data. Whenever you find yourself recognizing a possibility, you've got to ask yourself, am I being seduced to fill in? Is my brain filling in details that aren't actually there? Or am I really working on the account of what anybody would see? So here's another example. Task, not a difficult task, but for a certain age group, it is certainly a challenge. The interest, of course, is not whether it's true, but how do you know? Now, this is what Franz said. Franz said, well, like 51 is plus 51 are 102, but 51, if you subtract 50, you can add to 51. One from the other, one more, and you get 52. I'll let you read that again for yourself. The first thing to notice is that she's actually added 51 and 51. And this task comes from a whole sequence about relational thinking, where you don't need to do the calculation. You can look at relationships and make use of properties of arithmetic and equal signs. So you look at relationships and you can see that 51 plus 51 is the same as 50 plus 52, but not because they're both 102, but because there's been some shifting. So as a researcher, the question is, what is Fran attending to? It seems to me, and how is her attention changing, shifting? Now, Nicolina Mallara from Italy introduced the notion of babbling. Children in their cot and with very, very small babble sounds. They make sounds which begin to sound like sentences or words, and it's a step on the way for them learning to speak. And it's possible to think of Fran here as babbling in the sense that she's trying to express something, but she's not expressing it exactly the way an experienced adult would express it. In fact, I'll show you what the teacher says in a minute. It's a bit garbled, but she's quite likely to be babbling. You know, she's on the way to becoming more and more articulate. By contrast, I like the word gargling to refer to what people do in essays when you ask them to write an essay about what some psychologist said about something. So, for example, you know, an essay about Bruner and his 3 modes of representation, and you get when we were marking essays, so often you can see this person is simply throwing all these words at the page in various sentence structures, hoping that we'll recognize some of them and give them marks for it. I call that gargling, where it's like barking at print. You know, young children sometimes can say the words in print because it's as if they're reading, but they're not actually taking meaning from the words that they're reading. They're simply sounding out the words that are on the page. And for me, that's, again, it's a form of gargling. The teacher researcher said, that is interesting. You said that you can take one from here, pointing to the first 51, and add it to this one, pointing to the second 51, isn't it? Is that what you said? It certainly is not what she said. It may be a re-expression of what she said, but it's not what she said. So you can see this as a pedagogical action of reformulating something to show the child, to show Fran what being articulate would look like or sound like. Or you can see it as the teacher researcher intervening in a way which blocks off Fran from having another go at trying to express herself and feeling that she hasn't got it right because she didn't say what the teacher said. So what is being attended to by the teacher? So as a researcher with these 2 little pieces of monologues, you've got the question, what is being attended to? And for me, the question is, are you listening to what is actually said, or are you listening for what you want to hear? And the teacher researcher might be listening for rather than listening to. Now I need to do a time check and see where we are. Okay, I'm in a bit of trouble. Okay, I'm going to go to. Oh well, let's do that one. Okay, I'm going to do this, run through this one very quickly, because I want to make a point at the end of it. Adult 1 says to a 7-year-old, "Granddad is 79 years old. Can you work out when he was born?" Child thinks briefly, then announces 2040. And notice the rising at the 2040. There's the rising cadence of the question. Adult 2, pretend granddad is 80. Where did that come from? Child thinks briefly, then announces 1940. Adult 1 again. What is 100 take away 80? Child 20. Now, something very like this actually happened about 3 weekends ago. So, but I don't remember exactly what the child said, but it doesn't really matter, because the point is that what is being attended to in each case. And I've forgotten what that says because I can't read it. Anyway, it seems to me that each act of teaching, as I've said earlier, is an intervention in the learner's attention. And it's classic example here where the child hasn't the faintest idea where these questions are coming from. Pretend granddad is 80. What is 100 take away 80? What's that got to do with my original question? I'm caught up in the adult's attention, but I have no idea where those questions are coming from. So it's not going to help me do a similar question again in the future, because I don't know where the prompts came from. The adult's questions are instructions, but do not reveal to the learner how the question actually arose. And so the child is not actually in a position to learn anything other than adults ask you a whole bunch of questions and you have to answer them. But I need to move on. So teacher attention may be on a general method. The learner attention can only be on the specific questions. So the teacher has to work quite hard to get the learner to detect and experience the generality that lies behind. Now, all of these are meant to be examples of how what you notice is what you're attuned to notice, and that to attune yourself to notice mathematical thinking, you need to, I think you need to become aware in yourself of how attention shifts when you're thinking mathematically. We'll come to others in a minute. So this led me to write down the following. Hearing and seeing what is, and this was emphasized by Susan and Vicky last time. Hearing and seeing what is negative or wrong in what someone says or does is a focus on what should be, on the deficit. That's what I would call negative attending. In contrast, in the way it comes up, because there's a contrast to thoughts in your own head of what you're expecting. So it's the contrast between what you wanted and what you're thinking. And one of my experiences has been that it's not until I hear a response to my question that I become aware that I actually had an answer in my head that I was looking for. That takes a lot of work to really make that come to the fore in the moment in the classroom. And that's what the discipline of noticing it was intended to help with, to become aware in the moment that when I ask a question, I've already got an answer in my head. And so I need to be honest with learners about that. It's the distinction or the difference, which is what catches attention. That mostly what noticing comes about because of some change, some distinction or some difference. And it's very, very hard not to follow deficit attention with corrective action. Do this, do that, think this, think that. Now, hearing and seeing what is positive in what someone says, this is what Susan and Vicky were on about last time, was looking for the positive, for what could be, what's the potential. For me, in that Fran example with 51 plus 51, the hearing what Fran says as babbling rather than gargling means that I have a stance towards her, and hence a response to her, which is positive and supportive, rather than negative and basically dwelling in what's wrong. So hearing and seeing what is positive is much more helpful pedagogically. When it's aligned with your own thinking, it can unfortunately lead to imperative or directly inquisitive pedagogies. When not aligned with what you're thinking, it opens up the possibility for genuine inquiry and listening pedagogies. And minimizing a judgment of what someone says or does is very similar to working on accounts of rather than accounting for. Focus on what is, not on some theoretical view of what could be. That opens up the possibility for genuine inquiry, and the learner does not feel judged. A lot of kids feel judged in mathematics lessons, and that doesn't help them become positive towards mathematics. That's all about the classroom ethos that you establish, whether people feel judged or whether they feel it's something they can contribute to. Noticing lies behind all the kind of work you might do to work on your classroom ethos. And so the fundamental question, which for me makes noticing useful in any research paradigm at all, not just the discipline of noticing, but in any research inquiry, is when you've got something that you're going to call data, I ask myself, what would I have to be attending to that would lead me to say or do what the learner or learners has said and done? So try to enter what is the experience which generates the behavior, rather than simply focusing on the behavior itself. You can only be a conjecture, but at least it gives you a starting point. Now I'm probably way behind time. I wanted to relate to what Susan and Vicky did last time. This was one of the bits of work that they were looking at. They invited us to look at, and they used the words noticing, interpreting, and responding. And I'm trying to indicate that noticing isn't a trivial matter. It's about what catches your attention, but what you're interested in is what is the person who's behaving this way attending to. So what is it that that Joy is attending to in this pancakes problem? Interpreting is about looking for relationships and perceiving properties, and because that's the theoretic, that's the making use of theoretical constructs. And sometimes those can actually get in the way, but what you really want to have is actions become available to you to respond with. Very often something you notice triggers an action, but in between there has been either resonance with some past experience, metaphoric perhaps of your own, or some associations, which is called metonymy in Greek. An action becomes not just available, but gets enacted very quickly. And the thing is to learn to park. Discipline of noticing is intended to help trap automatic actions and make other actions become available. Okay. Now I need to change pages, and I'm running out of time. Okay, 23. I was led to make this slide when I was putting all this together. So I'm going to sort of move now into a sort of a summarizing mode. I want to leave time for questions, so I might cut short some of this. But anyway, there are imperative actions. My wife, Anne Watson, has coined this notion of imperative pedagogy, in which children are told what to do. Do this, do that. Take the second number and divide it by the first, whatever. There are interrogative actions, but they're actually imperatives. So what do we do next in this situation? It's basically an imperative, although it sounds like a question. How do we know? It's that use of that word "we," which is connecting to some amorphous group of mathematicians that the child's never met. There's a we-ness that the child is hoping to become part of, or has possibly decided not to become part of. That's also possible. And there are inquisitive actions, which are genuine inquiries. How do you know? So notice the difference between how do we know and how do you know? What did you do next? Please tell me what to do next. It's genuine inquiries. You're not thinking in a deficit fashion, you're thinking in a positive fashion. In how many different ways can you do something? Japanese classrooms are famous for this particular action, pedagogic action. Looking into what the child is doing, not looking for them doing what you want them to do. That interesting contrast. And then there are listening actions. And my friend Brent Davis talks about teaching by listening, which is really challenging. What is another way to do whatever it is we've been doing? Find a fraction between two fractions, whatever. Can you tell someone else how to do another question like this? Note it's another question like this. That's the generality dimension. And can you bring to articulation? Can you babble and work at it and bring to articulation over a period of time? And so you can quite succinctly express a generality of how to do another question like this, because that's what people need to learn to do if they're going to pass an examination. Listening to, not listening for an expected answer. And along the line of ethos is the conception of teaching, or conceptions of learning. So one way of thinking about learning is as a staircase. The child learns by analogy or by metaphor, goes up each step. And the assumption is that if you've gone up a step, then you're always at that step. But in my experience, I learn things and then I lose them again. And then I learn a bit more and then I lose it again. I go up and down this staircase. But a lot of pedagogy is as if once I've taught them this, the standard question, I've taught them fractions for 3 years running. Why don't they know fractions? And it's because staircase is really a bad metaphor for how learning takes place. There's this Brunner's spiral where you encounter the same ideas, but in a slightly different fashion and becomes more and more and more sophisticated. That seems to me to be have some potential to it. And there's the maturation. Learning is something which takes place over time. I have an expression that I coined some years ago. Learning takes place, let me just get it right now. Teaching takes place in time. Learning takes place over time. In fact, one of my respected teachers, Caleb Gatenio, said that learning takes place in sleep, because it's in sleep where the brain decides what to forget and what to remember. That's where learning actually takes place. So if an inspector comes into my classroom and says, I want to see some learning, I'm going to say, then you better go and watch me at sleep tonight, because that's when it's going to happen. Learning takes place over. Anyway, so why am I offering this? Because here is an example of how you could be using these three metaphors to listen out for, to listen to how teachers express how learning takes place. What is there a background metaphor of some sort, which is roughly staircase-like or roughly spiral-like or roughly maturation or possibly some combination of them? That's the sort of thing that one could be noticing and collecting data about. Okay. I wish I could remember what was here. I'm going to jump to 27. Conjectures about noticing. The more details that you discern in some situation and that you describe and report in a research report, the more I learn about your sensitivity to notice. The more somebody can tell you about what they observe a child doing, the more you learn about what they are sensitized to notice, because there are all sorts of things that could be noticed. Interpreting what someone is doing or saying is attending to, now I can't read that. Oh, there we are. Attending to relationships. Oh, that's good. Attending to relationships. In the discipline of noticing, care is taken to stick with details comprising relationships and avoiding spinning stories about what might be going on. That's what I was talking about, the distinction between giving accounts of and accounting for. I think oh my gosh, look at the time. Okay, I'm going to come to the finish. As with any professional development, or indeed any lesson, is there something that has struck you, something that you've noticed during this session, which you might want to work on or develop or use in the future? If that's the case, I hope it is, imagine yourself, so something has struck you, imagine yourself in an appropriate place working on that idea, perhaps even making use of it in some lesson. So if you would do that now for me, please. You don't need to put it in the chat, just do it for yourself. It seems to me you could argue that learning or professional development session or a mathematics lesson or a lesson about how to teach has some impact, some value, if new actions are available to be undertaken in the future. And this is exactly how the discipline of noticing works. I've asked you to think back what is something that has struck you that you noticed during this session. So that's the retrospective element. You then turn it into imagining yourself doing something with it, acting on the basis of it, or just using it, whatever. That is the prospective, because you're imagining yourself into the future. And then if you manage to do that, you can, it may actually happen. By imagining yourself into the future, it may actually happen that you notice in the moment an opportunity to do that. So the imagining forward, the prospective, is a way of encouraging yourself to remember to do something that you've at least one time wanted to do. And so I'm going to say that for follow-up, if you'd like to email me, that's terrific. There's my email. pmtheta.com is our joint website. Yeah, you have to search around for things. The slides are under John Mason and under presentations. It's the top of those. The book that I wrote, Researching Your Own Practice Using the Discipline of Noticing, that came out in 2004. And Questions and Prompts for Mathematical Thinking is a secondary, and it's got 100 mathematical kinds of questions to make use of. And so the discipline of noticing could be used to remind yourself and remind yourself and remind yourself to use a particular question, and to get into the habit of it until eventually the students start to use that question for themselves, and then you can move over to another pedagogic question. And there's a primary version there. That was a drift through noticing. Wow.